So hi everyone, welcome back to this another video of the object-oriented programming concepts. So in the last video we have learned about inheritance, which was allowing us to implement the concept of reusability by extending features of existing class and adding our own flavors to it and making it as per our own use or modifying it at our own use. In this video we are going to learn about the concept of polymorphism. So polymorphism allows an entity to take more than one form, or you can say it allows an entity to behave in multiple ways in different scenarios. So we can understand it in this way that a function can have different behavior. A function having the same signature, same prototype will have two different behaviors in two different scenarios. Yes, this is possible. Also, we can also take this in this way that an operator, which is say a minus operator, a plus operator, can have different values or different operations or different meaning in different situations. So this happens because of the concept of polymorphism, which is yet another important feature of the object-oriented programming languages or the languages which support the OOPS concept. So polymorphism can be generally classified into two ways. One is the runtime polymorphism and another one is the compile time polymorphism. I hope the screen is large and clear visible. Yeah. So one is the runtime polymorphism and another one is the compile time polymorphism. Now under the runtime polymorphism we have the function overriding, and under the compile time polymorphism we have the operator overloading. Remember that it is function overriding. Function overloading is a different thing which we will learn in the upcoming videos. So what's special about function overriding and operator overloading? Now before directly coming to what is function overriding and operator overloading, let us understand why runtime and why compile time. What is the meaning of these things? So runtime means that how an entity will behave will be decided during the runtime when the program is actually being run by the execution engine. So at that time how the function will behave is dependent upon the runtime behavior. And what is the meaning of compile time? Compile time means that how an entity will behave is decided by the compiler during the compile time. So runtime and compile time are two different things. One is deciding the behavior during the runtime of the program and another one is the deciding the behavior during the compile time. As simple as that. Keeping it clear. Okay. Now let us understand about what is function overriding. Now function overriding is an example of the runtime polymorphism. Now what happens is that in this a function with same name, same prototype, same signature behaves differently in different situations. Yes, this happens. So for understanding how this happens, let's go to our code editor. We'll write a simple code and we will see how different times different functions behave in same functions behave in different way. So it's better that we go to our code editor and see this interesting thing. So let's go to our code editor. So we are in our code editor. So these are the previous few stuffs which we have done previously. So I will erase everything. Okay. So I have done erasing everything. So now we are going to implement say function overriding. So for implementing function overriding, let's define two classes. Okay, so let's make a main method first. Okay, now once we have our main method, we will define two classes. One will be the base class, one is the derived class, which will be extending from the base class. Okay, so class, I'm sorry, yeah. Sometimes the intelligence works too much. So class base. Okay, now class base will not have anything special. It will have just a public member function, say void show. So void show will show something, say cout I am a base class. Okay, so void show will print that it is a base class. Okay, now once this is done, we'll make another class which is derived. Now derived will be deriving itself from the publicly from the base class. So it is deriving the base class. Now once it is deriving the base class, here what we will do, we will understand the function overriding. Function overriding says that a function with same return type, same prototype, same signature will behave differently in different scenario. So what is the function we have in the base class which we are going to override? So we are going to override this, so show function. So what I have mentioned, same function name, same signature, same prototype, but it can have different body. Yeah, so same function name which is show and same signature which is void show. So void show. Okay, nothing different, everything is same. Okay, now function definition or the function body can be different. That's up to you, how will you modify it. So let's write over here cout I am a derived class. Okay, so we see here is that show method is present both in base class also and also in the derived class. Okay, so we need to add a public over here, otherwise it won't be accessible. Okay, so we have a derived class, both derived class and base class both having the show function. Now we will see how the show function, which is overridden in different situations, behaves differently in different ways. Okay, so first we will make an object of base class. So let's take base b. Okay, so when we call b dot show, we will see that it will show that I am a base class. So as obviously it is showing I am a base class, no issues in that. But at this point of time, when you are making another class derived d, and when you are calling d dot show, at this time you will see that it will show that I am a derived class. Now why this behavior? Because this time the show method of that derived class is being called. However, there is also a show method in the base class, but that is overridden in the child class. So it will be getting more priority when you are calling it. So in this way we can see that the same function show, that is show, is behaving differently in different situation. When a base class is calling it, it is behaving in one way by printing that I am a base class. When a derived class is calling it, it is behaving another way by saying that I am a derived class. So this is a very easy way to understand function overriding. If you have not understood, I would recommend you to go back, revert, play this again and again on loop until you understand. This is very easy concept, nothing to complicate. Okay, now that we are done with the function overriding concepts, let's go and focus on the another type of polymorphism, which is the compile time polymorphism example, which is the operator overloading. So what happens in operator overloading, we are going to see now. So operator overloading is an example of the compile time polymorphism. So what does this mean? Operator overloading means of giving a special meaning to an existing operator without changing its original meaning. So what does this mean? That we have an operator, say plus operator. We know that plus operator is useful for adding integers, decimal numbers, floats number, anything. But in the example which we are going to see just now, coming shortly, we are going to see how this plus operator can be useful for adding to complex number. So what do I mean by complex number? If you have studied engineering or mathematics like that, you know that complex number consists of two parts. One is the complex part or the real part and the imaginary part. Now with this single plus operator, we are going to add two different complex number, and in complex number addition you need to keep a thing in mind that the complex part or the real part is being added to the real part, the imaginary part is added to the imaginary part. So we will achieve this same functionality using the plus operator. So we will see another behavior of the plus operator over here. So let's go to our code editor and we will see how can we implement the concept of operator overloading. So let's go to our code editor. So we are in our code editor here. So we have written something previously. We will erase everything. So let's go. Okay, so So we will just write the main method boilerplate code. We will write a class for complex numbers, so class complex. Okay, as I have mentioned earlier that a complex number consists of two parts, the real and the imaginary. So int real number, real part, and int imaginary as int. Okay, now that we are done, we will make a function for setting a value for the complex part and the real part. Okay, so void set value. Why we are doing this using this setter functions? Because we have not done up to now the concept of constructor, which will be the next video shortly. So in that, from that video onwards, you can directly use the concept of constructor to assign value to the private member variables. So for this we will assign values by using the setter functions, which is the set value. Okay, so we'll assign that. So it will take two parts, int r and int I. Okay, so it will assign real to be r and imaginary to be I. Clear up to now? We are doing nothing, we are just assigning value to the real part and the imaginary part. Okay, over. So now comes the important part where we will overload the plus operator and we will implement polymorphism. So our plus operator will do nothing, we will just write the plus operator, and what we will do here is that we will take another object as a parameter. We will return that object because we have to return the object as a couple of values so that the real part comes separately and the integer part comes separately, right? So let's overload the plus operator now. So for overloading the plus operator, we will have to write the class name, okay, followed by the operator keyword, operator, operator keyword, the operator which you intend to overload, which is the plus operator, and then here some parameters. So inside this parameter we have to return a new complex number after adding. So after adding, what you get is a new complex number, so you are going to return it obviously. And so for that reason we have the return type as complex number. Okay, now what are you going to add? I am going to add two complex numbers. So one complex number will be with me and another complex number will be passed to me as a parameter, as obvious as that. So for that I will have to write over here complex, say C2 or say C1, anything. Okay, so we have two complex number, complex C2 and the class in which the complex number is already defined. So we have the real part and imaginary part there as well. Clear? So we have to return the answer now. So we will define another complex number as complex answer. Okay, so inside the answer, the real part, answer dot real part will be equal to the present real of the present class plus C2 dot real. Okay, done. And also answer dot imaginary part will be equal to the current imaginary part which is already present inside the class. Apart from that, the C2 dot imaginary. Clear as per this? And at last we have to obviously return the answer. So we have to return answer. Right, that's it. So we have successfully overloaded the plus operator to add two complex number where we are adding the real part separately and the imaginary part separately. Okay, so our overloading is achieved now. So what we will do next work is to make two complex number, just add them and print out the output. So I will just do it now. So complex C1, and we are going to assign C1 dot set value to the imaginary part and the real part. Let the value of the imaginary part be and real part be 10 and the imaginary part be 5. Okay, similarly we will make another complex number, say C2, and C2 dot set value it will be say 5, 10. Okay, so here I am getting some error. So it is saying that this function is inaccessible. Yes, this quite obviously because they have not mentioned as public. So once you mention it public, it becomes accessible. That's a part of a typo which you can obviously ignore. See, errors are your friend. You have to welcome errors and learn from them. Okay, So we are done setting the values. So our next work is to assign or store this result or to directly print it as a string. The better approach will be to store the result. Okay, so let's write complex result equal to C1 plus C2. Clear as per this? Now we will print out the result or see out the result. The result of complex number addition is this. Okay, so the result dot okay, so to make the real part and the imaginary part accessible as well, so you have to make this as accessible, or even you can add another function inside this class so that you can just print out the result that way. Okay, that can also be done. So the better way will be to make this public for the time being so that we can get the answer directly. Okay, so let's write result dot real plus. Okay, and we'll give some space over here, and result dot imaginary. Okay, and after the imaginary, if you remember that we add an I over here to represent that yes, this is an imaginary part. So I done, our thing is done. So let's see whether the output is coming properly or not. So I am expecting 15 plus 15i as the result, which is the obviously you can see from here. So let's see whether our output is coming correctly or not. So if we run this, see we are getting the result is 15 and 15i. So if you want, you can add a plus symbol over here to make it much more clear and readable. So we can see that the correction or the correct complex number addition result is coming. So in this way we can see how can we implement the concept of operator overloading in C++, so that our plus operator can have different behaviors in different situations. We already knew that plus operator can be useful for adding two integers, say 5 and 5, say 5.5, 5.5, or even characters some point of time. Yes, characters are being added using the plus operator, but that's a different issue. But in this case we see that plus operator can also be extended or overloaded to be used to add complex number, the real number and the imaginary part separately. So that's how we implement the concept of operator overloading, which is an example of the runtime polymorphism or compile time polymorphism. I'm sorry. So this is the example of polymorphism. So that's all about polymorphism. In this video we have done the two types of polymorphism. So that's all about the concept of polymorphism. In the next video we will be understanding about the concept of constructors, and we will see how can we assign values to the data members directly while creating the objects. So that's all in this video. I will see you in the next video with constructor. Till then, keep learning and thanks for watching.